Alright, so in this video we're going to be going over a different type of word problem, so related rates. The goal of a related rates problem is to find the rate of change of one quantity using something that we know about the rate of change of a different quantity. So how can we relate rates of change of two different quantities? And so, before we get into some examples, I'd like to just outline the general procedure that we're going to follow in basically all these problems. So first, we want to draw a picture, which usually helps you to get an idea of what's going on. And then we'll write down an equation relating everything in the problem. Second, we differentiate the equation. That's what gets the rates of change to show up. And then we solve for the rate of change we want and plug in numbers to get the answer. So my plan for this video is just to introduce these ideas through a couple of examples, and we'll see many more examples in class and also in homework and so on. So for the first example, we're going to suppose that we have two cars. One is driving due east with a speed of 30 miles per hour. Then we have a bicycle, which is going due south with a speed of 10 miles per hour. And they start from the same point, and we'd like to know after 2 hours how quickly is the distance between car and bicycle increasing. So the first thing we need to know is we need an equation which relates the different things we have here. So in particular, we need an equation that involves the distance between the two objects in terms of maybe some things about their positions. So this is where drawing a picture helps, because we can see that if this car is moving straight, or this bicycle is moving straight south, and this car is moving straight east, then the distance between them will actually be the hypotenuse of a right triangle. So if x is the distance the car has traveled, and y is the distance the bicycle has traveled, then we know that the distance between the two, d, is equal to the square root x squared plus y squared. So that's going to be our equation. And we know from this information given to us that dx dt is equal to 30, dy dt is equal to 10. So we can use this information to figure about what dd by dt is. So d prime is going to be equal to 1/2 times x squared plus y squared to the negative 1/2. Then by the chain rule, we multiply by 2x x prime plus 2y y prime. So this is our equation for the derivative. So this is essentially step 2 and 3 and 1 because we've already solved for the derivative we want to know. We want to find d prime. And so the question now is, how can we find d prime at the time t equals 2 hours? Well, based on this equation, we'll need to know what's x of t at that point and what's y of t at that point. Well, after 2 hours have passed, we know that since the car is traveling at 30 miles per hour, it will have traveled a total distance of 60. The bicycle is traveling at 10 miles per hour, it will travel a total distance of 20 miles miles after 2 hours. So we know that x is equal to 60, y is equal to 20, and we've already set up here x prime is equal to 30, y prime is equal to 10. So we can just plug in all this information. So we'll have 60 squared plus 20 squared, the negative 1/2 times 2 times 60 is 120 times 30, plus 2 times 20 is 40 times 10. So we can simplify this a bit. We get 1/2 times, let's see, 3600 plus 400, the negative 1/2 times 120 times 30 gives us, I think, 3600 again, plus 400. So it turns out that we get 1/2 square root 4000. And you could probably simplify this a little bit, pull out a 4 or something like that. So it'll become just square root 1000. And this is meters or miles per hour. Okay, so that's how we solve that problem. I'm planning to go through one more in this video of a slightly different type. So let's suppose that we have a sphere. Air is getting blown into the sphere at a certain rate. So volume of the sphere is increasing at a rate of 3 centimeters per second, centimeters cubed per second. So maybe you can imagine the sphere as a balloon and we're blowing air into it. And I'd like to know, how quickly is the radius of the sphere increasing when r is equal to, let's say, 10 centimeters, or yeah, we can do this, 10 centimeters. Okay, so we have first to write down a formula for V. So V is equal to 4/3 pi r cubed. So this is something on an exam I would probably just give to you. You're not expected to memorize the volume of a sphere. I don't think that serves much point. But what is important is that we know that dv dt is equal to 3 because we're given that in the problem. So we can find by the chain rule v prime is equal to 4/3 pi r cubed times 3r squared times r prime. Then if we isolate r prime, we get that r prime is equal to 4 pi r squared divided by v. Now we're told that we're interested in the time when r is equal to 10. Divided by v prime, my mistake. So that means we have 400 pi divided by v prime, which is 3. And that will be our final answer. Okay, so I'm not going to do too many examples in this video. I think I'm just going to leave it at that. But you can see the general procedure, I hope. You set up your equation relating the quantities in the problem. You take the derivative, and then you plug in all the information that you know in order to get your final answer. And in these sorts of problems, I strongly recommend you always start by drawing a picture, because that can help you a lot to sort of organize what is it that you're trying to find, what is it that you know, and how can you write down an equation relating all of these things.